Hi friends, welcome to this session. Today we will learn about the unit step signal, unit impulse signal and ramp signal. These are the basic signals. Before go into the signal and system world, we should know about these signal. These are the basic signals. First of all, unit impulse signal. Unit impulse signal. Unit impulse signal is denoted as del of t for continuous signal, for continuous impulse signal, and del of n is used to denote the discrete time unit impulse signal. Discrete unit impulse signals. Now continuous del t, that is the continuous unit impulse signal, may be defined as del of t equal to 1 for t equal to 0 and 0 for t doesn't equal to 0. Mathematically, del t equal to 1 for t equal to 0 and del t equal to 0 for t doesn't equal to 0. That means that the anywhere in the time axis its value is 0, but in case of t equal to 0 its value is 1. Physically, if we think about the impulse signals, we can correlate the impulse signal with the other environmental occurrence of signal, like the surge current, the lightning. You may think that physically a huge amount of force act very small time, very rare time. That's the impulse signals behave like that. A very huge amount of force act in a very small time, very shortest period of time. That's the good example of a unit impulse signals. If its strength is unity, then it is called as unit impulse signal. It may be, the strength may be higher. For unit impulse signal, graphically can be represented as, that's the graphical representation of unit impulse signal. That's the graphical representation of unit impulse signal. Mathematically, the unit impulse signals express the strength as the area under the unit impulse signal. So the another representation of unit impulse signal is that this is the signal, this is the 1 by del period of time, this is the y-axis value, del t y-axis value. This is also another representation of a unit impulse signal. Now we go for unit step signal. Unit step signal. Unit step signal, in case of continuous time signal, unit step signal, you may define as ut equal to 1 for t greater than or equal to 0 and 0 for t less than 0. Graphically, it can be represented as, for continuous signal it can be represented this like, or for ideal case it is For ideal case, it is this one. This is the unit unit step signal. For unit discrete signal, it can be expressed as u of n, that is equal to 1 for n less than, for n greater than or equal to 0, and 0 for n less than 0. Discrete unit step signal can be represented graphically as graphical representation. This one, the 1 2 up to 3. These are the unit step, different signals. This is n, this is u of n. Now we will go for the ramp signal. Ramp signal is a basic signal that can be defined as expressed as RT equal to T for T greater than equal to 0 and 0 for T equal to 0. T equal less than T less than 0. RT equal to T for T greater than equal to 0 and 0 for T less than 0. For T less than 0. Graphically it can be represented, this one graphically can be represented this. Here one thing you can mark that, it represent the slope, how the signal mainly indicate the slope, how the signal change with respect to time. For unit ramp signal, the slope is 1. For unit ramp signal, slope equal to 1. For other ramp signal, example 5 delta 5 RT equal to, can be represented as this 5. This is the 5. This is the slope represent. Okay. Now how the relation between the unit among unit step ramp and impulse signal. UT, unit step signal, equal to time integration of del t to RT is the time integration of UT 3. Del t is the first order differentiation of UT. These are the how the signals are related to each other. Thank you. I think this session is more informative to you. Have a nice day. Thank you.